And welcome back to Mr. Reed Math, where we like to take the mystery in math and make it past tense. And today what I want to do is really just start up a quick series of review of some things we've been going over in class with regards to three-dimensional shapes and how we're finding the surface area of shapes and we're finding the volume of shapes. So this first video is hopefully going to be pretty quick, we'll see, but we're going to talk about prisms. Okay, and prisms, they can be rectangular prisms, square prisms, triangular prisms, octagonal prisms, all sorts of different shapes. But let's just start with the basic of the basic. Let's start with a rectangular prism, all right, such as a cereal box or something like that. What we're going to start with, ultimately we're going to find the surface area and the volume. But let's start with the surface area. And what it really boils down to is I'm trying to figure out how much cardboard was used to make this box, or how much wrapping paper would I really need to cover it. When we're talking about surface area, we're talking about the outside shape of it, okay? Not the inside, not how much it holds, but what would it take to effectively wrap it, okay? And if you can imagine, if you were to take a cereal box and just kind of put a slit down some of the seams so that you could flatten it out, this is what you would have. And if it's a rectangular prism, because what we're using as a base is a rectangle, all right? And so we have a base and we have a top, which are identical. They're parallel, and they're connected by other rectangles, or parallelograms technically. And so when we lay it out flat, what we have is, here's the base, there's the top, okay, or the two bases if you prefer, and then this would be the front, this would be the back, and these would be the two sides. And if you want to know how much wrapping paper there is, what you could do is you could literally sit here and calculate the area of each one of these rectangles, add them all together, and you'd have your answer. Now there's a little bit quicker way to do it, and it looks kind of like this. But to be honest with you, if you want to do it the other way, that's fine. I won't hold that against you. If that gets you the answer, great. But what a lot of people typically do is they recognize, well, okay, the bottom and the top are going to be the same. All right, so I'm going to calculate the area of the base, and I'm going to multiply it times 2. All right, and then I'm going to calculate the area of the front, and the front and the back are going to be the same. So I'm going to calculate the front, and I'm going to multiply it by 2. And then I'm going to do the same thing with the sides, because they're going to be the same. So I calculate the area of one of the sides, multiply it by 2. And that's where these numbers come from. If it has a width of 12 inches and a depth of 4 inches, well, then you just multiply 12 times 4, multiply that times 2, and so the top and bottom together give you 96 inches squared. All right, hold on to that. We're going to move down. Let's figure out the front. All right, the front is 12 times 16 inches. 12 times 16 times 2, that'll give you 384 inches squared. Hold on to that one. All right, we've got 96 so far, and we've got 384. And then when we do the left and the right sides, we got 4 times 16, again, times 2. That gives us 128 inches squared. Add all three of these together, and that gives you the full dimension of the surface area, and it would be 608 inches squared. All right, whatever the shape is you're working with, you literally just have to figure out how many sides am I dealing with, what is the area of each side, and then just add it all together. It works the same way if you've got a trapezoid or a parallelogram or an octagon, whatever. You just need to count and recognize how many sides there are, and then you calculate the area for each side, add it all together, and it's as simple as that, okay? So that's how you find surface area. Now, volume of a prism, that's the second part, is a little bit, well, it depends on the shape. I mean, honestly, for a rectangular prism, volume's pretty simple. Okay, but let me explain it. Let me break it down. Before we go to this, you've probably heard length times width times height. And if you're dealing with a box, if you're dealing with a rectangular prism, that's true. But hang on, let me put a pause on you, because the safer way to do this is figure out what is your base, all right? And then you're going to find the area of the base, which would be, in the case of a rectangular prism, it'd be your width and your depth, or your length or your width, whatever you want to call them. But it'll be these two numbers down here, multiply them together, and the area of your base in this case would be 48 inches squared. And then you take that, and then you multiply it times the height of your object. Okay, this is the safer way to think about it, because, hang on, they're not all going to be rectangular prisms, and I'll show you what I mean in just a second. But as long as all you're talking about is a box, yeah, you can just take the three numbers, multiply them together, done. Okay, and then you come up with 768 inches, cubed. okay? Because now we're talking about 3 dimensions, okay? So you're going to come up with inch times inch times inch, which will be inches cubed. All right, so any questions about a box? I hope not. That one's quick and easy. But what happens if we have something like, if I can make my fingers work, here we go. What happens if we have something like a wedge of cheese? That'd be a real big wedge of cheese, 6 inches. Okay, well anyways, we have a triangular prism, okay? Well now, what's the base? And let me point this out. If you have a prism, all of the sides or the lateral faces, they're all required to be parallelograms, and in most cases they're rectangles. All right, you can't have a triangle or a pentagon as one of your lateral faces. If you have something that's not a parallelogram, then it has to be the base. So in this case, the triangle has to be your base. So we go back to the rules that I showed you on that first one. Is you start, step 1 is you find the area of the base. All right, so in this case we're going to find the area of the triangle. All right, and the way we do that is it's just like we've always done with the triangle. You take the base, well, the base of the triangle times the height. It would be 10 times 4 divided by 2. So 10 times 4 divided by 2 gives you 20 inches squared. That's the area of the base. Now the other 3 pieces around that triangular prism are going to be, well, they're going to be rectangles in this case. All right, so that becomes a simpler matter of we find the area of the base and then we multiply it times the height, and then that will give you the volume. The volume of that triangle would be 20 inches squared times 6, which is going to be 120 inches cubed. Keep in mind, we're talking volume now. We're not talking about surface area. Now, if it was surface area, you'd find the area of the base, multiply it times 2, and then you'd find the area of each of the 3 rectangles, add that together, and that's how much wrapping paper. But the volume is the inside storage capacity of it. So, once again, find the area of the base. That's the triangle. Then you multiply that times the height, and you're done. Okay? If it's sitting on its side, you might think, well, gee, I think the rectangle on the bottom is the base. The base doesn't necessarily mean the orientation. The base means what is the shape that's naming the structure. This is a triangular prism, so the base is a triangle. Okay? So you find the area of this triangle first, and remember what I said. If one of the pieces is not a parallelogram, then that piece must be the base. So the triangle must be the base. So 14 times, this says 8 inches is your altitude for that triangle. So 14 times 8 divided by 2. That'll give you the area of that triangle. And that's what I wrote down here. 8 times 14 divided by 2, 56 inches squared. All right, that's the area of your base. Then you take the area of your base and just multiply it times the height of the object, which would be 5 inches. So 56 inches squared times 5 inches is 280 inches cubed. All right, one more example and we're done with this one. Okay. What if it's a trapezoid? Okay, a trapezoid's not a parallelogram. Okay, it's something different. So that has to be your base. Okay, the trapezoid is what defines this this object. Okay, it's a trapezoidal prism. All right, so for this trapezoidal prism, you must treat the trapezoid as the base. So we find the area, that's number 1, of the base. We multiply it times the height of the object. The way you find the area of a trapezoid is you take the average of its 2 base sides and multiply it times the height. Okay, so the way you find the average is you take 9 plus 5, divide by 2, that gives you 7. Okay, and then multiply that times the height of the trapezoid, which gives you 35 inches squared. That is the area of the trapezoid. Now, let's turn it 3-dimensional. You multiply the area of that trapezoid times the height or width, whatever you want to call it, the depth of the figure. And so you take 35 times 6, and that's what gives you the 210 inches cubed. All right, that is this lesson and how we treat prisms with regards to surface area and volume. Hope you enjoyed it. I'll see you for the next one.